It's Mr. Lawrence here, and we're going to be working on graphing linear functions and equations, and not just linear ones, but we're starting with linear ones. We spent a couple days on linear ones, and then we'll do something else. All right, now you want to have some graph paper. Did I mention you need some graph paper? Graph paper is very important right now. Use graph paper notebook for right now. It's fine. All right. I know most of you could probably get a pretty good guess of how to graph this, okay? Now, you're going to do it a good way, and that way is going to work. And I'm going to start off doing it that way. I'm going to do like 2 problems the way I think you're going to do it, but then I'm going to show you an easier way. Okay, now, you notice my Cartesian coordinate system here, okay? I've got x on the horizontal axis, always, and here I have f of x. Just to note, f of x can be replaced by y, okay? Remember, not all relations are functions, not all equations are functions, and so sometimes we have to use y. In fact, before this year, I would have used y almost all the time because functions weren't as heavy a topic in Algebra 1. With the switch to Common Core, they have. So you see me use f of x, g of x, etc. All right, so now, to get this... to get some points on this line, how many points am I going to need to get? Anybody know? What's that, Sean? Well, Sean, I need at least 2. 2 points to make a line. For example, if I put a point right here, oh, you know what I'm going to do? Hold on a second. I'm going to use some really cool points. I just thought of doing this. I don't know why it took me so long to think of it. Oops, where'd you go? Point, get back here. Okay, oh, I like that one. Nice and big. Okay, now I'm going to fill it in because I don't want you drawing open circles. They need to be filled. There we go. We should fill it with black, I would think, since the point is black. All right. Anyway, if I put a point right here, how many lines can go through that point? Anybody know? Well, there's an infinite number. Okay. There's a line, and none of these are lines because they don't have the double arrowheads, but there's a line right, well, I missed it, didn't I? Okay, there's a line right there. And let me put an arrowhead on him. I'll make him red just so he stands out. Let me make him a little bit thinner. Ooh, that's good. I like that thickness there. So there's a point right, there's a line right there, but there's also... Can't seem to get that line. There we go. There's also a whole bunch of other lines. Okay, for example, here's the one we did first, but there's also this one here, like this, right? And then there's this point. Oops, I'm just having smartboard fits here. Okay, that one. And we can just keep going like this forever. There's actually points, if I don't limit myself to 2-dimensional space, there are points coming out of that line, out of that point, like out into the smartboard at all different angles. So there's an infinite number of lines. But if as soon as I put a second point on, like, let me see, can I grab that point or is it going to be difficult? It's going to be difficult, so that's no problem. I should come over here and infinitely clone this guy. So let me do that. Properties. And we're going to fill them up. And then we're going to infinitely clone them. And that way I won't have to worry about it. Okay. And so as soon as I put a second point, say here, now only one of those lines is on both points. So I need a minimum number of 2 points. I like to use 3 often because it helps me draw a better line on paper. But 2 is the minimum number, okay? So I'm going to make a little table. Now I'm not going to go 1, 2, 3, 4, 5. I'm going to pick 3 x values, okay? And since x is, or this coefficient is 1/2, I'm going to limit myself to even numbers. I love to pick 0 for x because it makes the math so simple. I'm going to pick 2 and I'm going to pick 4, okay? Because it's easy to do. So now I'll figure out what f of x is. By the way, I should get rid of all these extra lines here. They don't really belong in the problem. Nope, don't belong. Get out of there, little lines. All right, get my points out of there. I'm going to need those points. I just don't know where I'm going to need them yet. And so let me do f of x. And so if I do f of 0, I should get 1/2 times 0 plus 3, which is going to be 3, right? And then I have to do f of 2, and that'll be 1/2 times 2 plus 3. And let's see, that'll simplify to 1 plus 3, which is 4. And then I have to do f of 4, which is 1/2 of 4 plus 3, which I believe will come out to be 5. So now I have to graph these 3 points. My x-coordinate is 0, my y-coordinate is 3. So 0, 1, 2, 3 is right there. That's a very, very special point. In fact, I'm going to make it a different color. It's so special. Yeah, you special little point. I wonder if anybody knows why you're special. Ooh, dear, I did the 4 there. Let's see. Ooh, there he's nice and special now. All right, now I need the point 2, 4. So it's 1, 2, 1, 2, 3, 4. All right, and then a third point is at 4, 5. 1, 2, 3, 4, 5 right there. So now I'm ready to draw my line. And so this is very important here. Your line needs to go forever. Ever and ever and ever. If your line doesn't go forever, then it's not a line. It's only a line segment, right? So you need to make it take up the whole graph. Some of you just kind of draw a little stubby thing. Nope, not going to happen. And you need arrowheads on the end. And I will take off on tests if you choose to not do that. Okay, it needs to go forever, and it needs to have arrowheads on both ends. All right, there's my line. I'm going to come back to that in a minute. Okay, that was pretty easy. Let's go down to the second problem I have here. And, oh, Mr. Lawrence, you got to give us ones with fractions. That's no fair. Yeah, it's fine. Just start working with the fractions and they get so much easier. All right, so I've got x and g of x, and I'm going to plug in 3 values. I love to pick 0. I think this time I'm going to pick 3 and 6. Could have picked -3, -6, 12. You're in honors algebra. I shouldn't have to explain that to you. You figure out why. It's okay. So now I've got to do g of 0. And that's going to be -4. I'll leave the work to you. G of 3 is going to be -3. And G of 6, I'm guessing it's going to be -2. And I'm right. Okay. So I need 3 points. 0, -4. 0, 1, 2, 3, 4 is right there. Okay. 3, -3. 1, 2, 3, 1, 2, 3 is right there. And 6, -2 is right there. Okay. Now, I'm going to get my line in here. Am I done? Hopefully you realize I'm not, because I haven't drawn a line yet. Haven't drawn a line. Okay. Now, I don't like it to be black because I like it to show up a little bit better. All the graph, the axes are black and that kind of doesn't stand out. There we go. Simple. Very simple. I know an easier way. I know an easier way. Do you notice the coordinates? Remember I said the one point was special? We got another special point right here. I'll highlight it. That's my special point there. Okay. Do you know the coordinates of that point? The coordinates should be, the x-coordinate should be 0, and the y-coordinate should be -6, or the g of x coordinate, -4, excuse me. Better correct that, or Sean will correct it for me on Wednesday. Anyway, 0, -4. You look at that. See that -4 there? Let's go up to this other problem here. What were the coordinates of the special point? Highlight that special point for you. There we go. Nice and highlighted. And its coordinates would be 0, +3. I'll be darned. Look at that. Yeah. Do you know why that point's special? That point is on the y-axis. So it's called the y-intercept. Y-intercept. Okay? It's the place where the line crosses the y-axis. It's the y-intercept. Now, this is very important. What I just said was very important. The y-intercept is where a line crosses the y-axis. There is an x-intercept. I don't happen to know it off the top of my head. I could figure it out. It's not quite as useful as, say, the y-intercept is, but I could find the x-intercept. The x-intercept will be here because it's where the line crosses the y-axis, or x-axis, excuse me. So an intercept is a place where the line crosses an axis. Okay, so the y-intercept crosses the y-axis, the x-intercept crosses the x-axis. All right, if your equation is like a function, like f of x equals something, you know, f of x is alone, there's no number over here. Or if it said y, oops, I'm in highlight mode, sorry about that. If I said like y equals 1/2 x plus 3, you see how this y is alone? There's nothing here, it's just one y. Well, then your y-intercept is always sitting there. And I'll teach you a form in a moment. All right, it's always sitting there. Yeah, that's not a coincidence. So now I have to graph this one. And I'm going to go ahead and do x and h of x, do the table. Oh, no, I'm not ready to graph that one yet. Hold on a second. All right, now there's something else I want you to notice. Ladies and gentlemen, I'm trying to record a video. Sorry about that. My kids are not getting along. So there's something else I noticed here. Look at this. If I move from one point to another point, look at this. If I go up 1 and I go right 2, I get 1 and a 2. Look at that. A 1 and a 2. That's really interesting, isn't it? Yeah. Let's check this one. I go up 1 and over 3. 1/3. Yeah, 1/3. Now, it works here too, but with that black solid line, it's not going to show up as well. But if you go up 1, 2, oops, I'm sorry, I went too many. 1, 2, 3. There we go. See, I get the 1/3 again. Now, it doesn't matter which 2 points I pick on this line. For example, I could go from this highlighted blue point to this point here. Watch what will happen. Get rid of those. And I'm going to go up 1, 2, okay? And then I'm going to go 1, 2, 3, 4. And if I put the 2 over 4, that simplifies to 1/2 every time. This is called the slope, all right? This is called the slope. And you find the slope. This only works when y is alone or f of x is alone. You find the slope as the coefficient on x. It's the number in front of x. This is the y-intercept. The y-intercept. The form I'm talking about is called slope y-intercept form. Technically it's called slope-intercept form, but I love to call it y-intercept so you remember which intercept you're finding. And it looks like this, y equals mx plus b. All right? And m is the slope, or in other words, the movement. The movement, okay? The b is the y-intercept. The y-intercept. Yeah, the place where the line crosses the y-axis. So if I have y all by itself, or if I had like f of x equals, 1/4 x plus 5, first thing I would do is I would do the y-intercept. I'd plot the y-intercept, and then I would use the slope. I would move up 1 and right 4 to get my next point. All right, let me show you how that works here. Let's see. There it is. Okay, here I have an equation. H of x is alone, right? It is in this slope-intercept form. It looks like y equals mx plus b. Okay, my y-intercept is this number. In this case, it's -5, so it's the point 0, -5. So I'm going to go to 0, 1, 2, 3, 4, 5, and put a point there. All right, this is my slope. Now my slope needs to be written as a fraction. What's 2 as a fraction? Well, it's 2 over 1. Now, the top number tells you how much to rise, and the bottom number tells you how much to run. Run, what does that mean, Mr. Lawrence? Rise and run. Well, rise is your vertical movement, up or down, and run is your horizontal movement. You go toward the sign that the number has. So a rise of 2 is to go up 2, so I'm going to go up 1, 2. A run of positive 1 is to go 1 to the right. Boom. There's my second point. I can now draw the line. So now I'm going to go up 2 over 1, and now I can get a whole bunch of points. Why would I want all these points? Just so I can draw a better line. More accurate. Okay, so let's see here. 1, 2 over 1. So it looks like it's going to go something like that. And I need arrowheads on here, right? I'll make it a little bit thinner so I can be more accurate. The more accurate you are, the better your line will be. Ooh, a lovely shade of pink. All right. There we go. There is my graphed linear equation. And remember that slope thing I did, it works no matter what points I use. If I move from this point here up to this point here, watch what'll happen, okay? So I'm going to rise 1, 2, 3, 4, 5, 6. And then I'm going to run 1, 2, 3. So I went up 6, I rose 6, and I ran 3. Oh, I ran 3, not 6, Mr. Lawrence. And so it would be 6 over 3, my slope, which simplifies to 2 over 1. Now, almost always I want you to simplify a number down to like a whole number if possible. The exception to that is with slope, because it's really cool to see the run. It really helps us out sometimes. So if I ask you for the slope and you tell me m, remember m is the movement, you tell me the slope and you tell me 2, I'll give you full credit. If you tell me the slope is 2 over 1 and we're graphing, I will give you full credit. Okay, if we're talking about slope. If I just say, hey, what's 10 divided by 5, I expect to hear 2, not 2 over 1. Okay? All right, let's do another one down here. And let's see here. Y is alone. Y is alone. So I'm in this y equals mx plus b form. Oops. Hey, you might be wondering why they call it b. Because I begin by plotting the y-intercept. I begin by plotting the y-intercept. I always plot that first. I can't use the slope unless I know a point. All right, so my y-intercept is going to be 0, 8. So I'm going to go up to here to 0, 8, which should be right there. That's the point 0, 8. And then I need my slope. My slope is the number in front of x, the coefficient on x. So it's 3 as a fraction over 1. Uh-oh. I'm going off the graph. If I rise 1, 2, 3, I'm off the graph. I can guess it's about there, but I'm not as accurate. Is there anything else I can do? You know, thinking that fractions are equivalent, like, 6 over 2 is the same as 3 over 1, maybe there's a way I could change this fraction so it looked different, but still equal the same thing. I mean, 6 over 2 wouldn't work because if I go up 6 and over 2, I'd be off. But lines go forever, don't they? What would happen if I went down 3 and back 1? If I change the slope to -3 over -1, the best slope is still this right here. But what about if I thought about it like -3 over -1? So if I went down 1, 2, 3, and then left 1, would I end up on the same line? 1, 2, 3, left 1. How did I know to go down? Because I made the 3 negative. How did I know to go left? Because I made the 1 negative. Let's see if 1, 2, 3, 1, if we're going to hit that guesstimated point up there. It looks like we're going to. Yeah, now let me change the way this line looks a little bit so it stands out better. Properties, and boom. Make it thinner, and I'll make it a nice bright red. There we go. Yeah, look at that. Look at that. So I can interchange the slopes. Hey, normally we don't do this. Normally do not do more than one line on a graph unless told to. Okay, in this one, I'm going to go ahead and do another one on here. I'm going to do y equals, let me see, let's go with negative 1/4 x plus 2. Okay, so I know my y-intercept is 0, 2. So I'm going to plot 0, 2, and plot that in a different color. There we go. Now I've got the slope of negative 1/4, don't I? So m is going to equal negative 1/4. Who's that negative belong to? Well, you have to ask yourself, is negative 1 over negative 4 equal to negative 1/4? I don't think so, because a negative divided by a negative is a positive. That would be positive 1/4 in disguise. But I could do negative 1 over positive 4. Then again, I could do positive 1 over negative 4. Don't believe me? Watch, I'll get a couple points with each. First, I'll use this one. All right, so I'm going to go down 1 and then write 1, 2, 3, 4. Down 1, 1, 2, 3, 4, and there you go. All right, now I'm going to highlight this one. Oh, circle it in red. Going back to the original point, this y-intercept, I'm going to go up 1, but then left. 1, 2, 3, 4. Okay, I'm going to go up 1 and then left. 1, 2, 3, 4. And there you go. All right, and look at that. All those 2 red and the 3 blue points all are on the same line. If they weren't on the same line, I wouldn't be able to draw a line through them. Yeah, they're called collinear. Collinear, meaning they're on the same line. That's all it means. Let me change that color and put an arrowhead. Got to have those arrowheads. All right, so what did we learn today? We learned a better way to graph, a more efficient way to graph instead of making a table. We learned what's called graphing from slope-intercept form. It only works for lines. Actually linear functions specifically, if y is alone in the equation, in a linear equation, then we can tell the y-intercept, it's the constant, it's the number that's not attached to a variable by multiplication, and we can tell the slope of the equation because it's the coefficient of the x variable. But remember, y must be alone. All right, so we'll get some practice with this tomorrow. Here's your video quiz. Now, I got a feeling some of you kind of blew the videos off last week before the test. There's no way some of you could score 9 or 13 out of 29 and tell me you prepared. So we're going to have a few more video quizzes in, even though it makes a lot of extra work for me. I've got to hold you accountable. All right, so question 1 is, in a linear equation, when y is alone, or f of x is alone, what 2 important facts about the line do you know? All right, question 1a, just to follow up, what parts of the equation tell you these important facts? So you need to answer 1 and then answer 1a. All right, Mr. Laurence signing off. Have a good night, everybody.